This circuit is a non-inverting operational amplifier, and let's find the gain AV, which is the output voltage divided by the input voltage. So the first steps when solving an op-amp question is the ideal op-amp rules. Is we know that the input terminals are super high impedance, so there's 0 amps flowing into the inverting and the non-inverting input. We also know that the voltage is the same at both terminals, so if we have voltage in going straight into the non-inverting input, we can instantly say that the inverting input has also got a voltage of Vin. We can see that if we do a KCL analysis on this inverting input terminal, we'll get an equation in terms of Vin and in terms of Vout. So let's do the KCL and see what we get. KCL tells us that the current going out of a node is 0 amps, and from this node there's only two paths that the current can flow, since none goes into the op-amp. We have I1 and I2. From Ohm's law, V equals IR, so current is equal to voltage divided by resistance, and if this is 0 volts, then the current I1 is equal to Vn minus 0 divided by R1, and the current I2 is equal to Vn minus Vout divided by R2. Now we can rearrange this equation and solve for Vout over Vn. And from this we can see that we can easily move Vout onto this side of the equation, and then we can rearrange that to find the gain AV. So we can see that our gain AV, which is 1 plus R2 over R1. And you can use this by taking the input voltage and multiplying it by the gain, and that will give you the output voltage. Since Vn multiplied by the gain cancels the input voltages and leaves you with just the output voltage. So if we had 2 volts coming in here, and let's assume these are both 1000 ohms, 1000 divided by 1000 is 1, 1 plus 1 is 2, so our gain is 2. So if we take 2 volts, multiply it by a gain of 2, that gives us 4 volts at the output.